All right, hello and welcome to Double Angle Identities, Part 2. Now, our first example here says to express 2 tan x divided by 1 plus tan squared x as a single trig function. Now, I personally think the easiest way to do this is to jump right in and switch out all these tangents with the old quotient identity. In other words, sine over cos. Now, if I haven't mentioned it already, I will mention that there are lots of ways to do these proofs. What I'm doing here is one way. There's probably 4 other ways you could do each of these proofs, just so you know, and they'd all be correct. So this is my first step. I've switched out for each tangent or tan squared. I got sine over cos, or sine squared over cos squared. Now I see I've got some complex fraction stuff going on. So what I'm going to do, I'm going to multiply the top and bottom by cos squared. And that's going to get rid of all of these complex fractions. So here we go. What do we got on the top? Well, we have 2 times sine. And one of these coses canceled, so I just got one of these coses left. Okay, so there's the top. On the bottom, I'm going to have a cos squared times 1, so there would be cos squared. And then plus, and then here the cos squareds would cancel, so it would just be plus the sine squared left on top. Well, I think you might recognize that cos squared plus sine squared is 1. And at the same time, 2 times sine x times cos x is the same as sine of 2x. So now, I think I'm done because this is a single trig function. All right? See, back here we still had sines and coses. We had 2 trig functions. Now we only have the 1 trig function, so we are done with that example. And now, the last example. Okay, here's back to a proof. We're going to try and prove the following. I'm going to try to prove that secant squared is in fact the same thing as 2 divided by 1 plus cos 2x. All right, so let's see what we can do. What can we do with secant squared x? Really not much. I'm just going to write it as 1 over cos squared x. That's about all we can do with that guy. So the real work is what can we do on the right? So there's the top. There's the bottom. Now, here I'm going to do a substitution. I'm going to switch out cos 2x. But the question is, which one do I use? Do I use this version of cos squared minus sine squared? Well, I could, but you know what? I don't think it's going to get me very far, or at least it would take an extra step. Now, what are my other choices here? My other choices are I have 2 times cos squared minus 1, and then I also have 1 minus 2 sine squareds. Okay, so which one do you think is going to be the best choice? Well, let me make it obvious to you by putting this little arrow here. This is the one we want, and let me show you exactly why. Okay, it's not that the other ones are wrong, but they would involve an extra step. Whereas this one here, I see the 1 on the front and the minus 1 that I just brought in, they're going to cancel. And that's kind of nice, because then I can look at what's left here. You know, here's what I got, a 2 over 2 times cos squared x. And I can go, hey, let's cancel off those 2's, and by golly, I've got the left side equaling the right side. So it just means that by making this choice as compared to the other 2, I didn't have to do any extra steps. It was really just a matter of canceling, and I was there. And that takes me to the end of this example. So we'll talk to you in a bit.